Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. I would now like to welcome Shweta, Omkar, and Vivek, our speaker for today's session. Shweta and Omkar both works as a cloud consultant at Rapid Circle. And of course, we have our Azure Happy Hour host, Vivek, who works at Microsoft as a senior cloud advocate. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. But for now, I will hand over to Vivek to begin the session.
Yeah, thanks, Rashmita. And I would like to welcome Omkar and Shweta to Azure Happy Hour. And we basically it's of Azure Happy Hour started 2 years back. We started like every Friday. We have a conversation on Azure and open source with Azure and other things. And people who build on Azure come up here and talk about how they build their products on Azure. And it's interesting that we you know we do it every Friday nowadays. We are also doing it on Wednesdays as well. So it's like we find it more like happy hours on Wednesdays as well, so which is good. And an interesting topic, today's topic, right? So this is something you know I, I did a couple of these things way back when I was in HCL, because it's an enterprise. When it comes to startups and other things, I don't see them focusing on more of governance and other things, which is a very important aspect. But I think I know I worked in a couple of these areas while I was at HCL, while I was doing enterprise DevOps for one of the company. So interesting topic from a governance perspective. So I will just hand over to you to get kickstart the session, and of course I'll be asking you questions in between. And from the audience, please make sure you key in your questions in the chat. I'll pick those questions as well, and make sure that we ask the speakers here. And at the end of the session, obviously we'll open the mics as well so that you can ask directly to Omkar and Shweta, right? So go ahead, Omkar and Shweta, just get started with it.
Yep.
So I am sharing my screen, Omkar.
Yes, you can share
Let me
your
know when
screen.
you can see it.
Yes, so we're going to Shweta is sort of going to orchestrate the deck for me in the beginning, and then
Yeah.
she'll run into a demo for the product. Great. So first of all, thanks Vivek for this wonderful opportunity. We're really excited to engage with the community over here. A lot of people joining on a Friday evening, so that's great to see. Looking forward to this conversation, and I think we can start. Shweta, I think we can move on to the next slide with the intros
Yeah.
and kick off. Okay, so basically, we are representing Rapid Circle over here, which is a Microsoft partner company. We have consulting expertise on Office 365, Azure, and SharePoint. We have had we are a decade-old company, and last year we also bagged the Partner of the Year award for Teams adoption through our through the kind of work we did in Netherlands. We also have a suite of products under the brand name Leap, and that is where Shweta and I come into picture. We work at the innovation lab within Rapid Circle, where we build products that are tightly aligned with the consulting arm. So we're continuously on the lookout to find opportunities to help customers beyond just consulting, and also build products that can help even our consultants and our customers build great solutions. We operate in Netherlands, India, and Australia, and a slight shameless plug over there. We are also hiring, so do get in touch. I'll introduce myself, and Shweta, then you can take over for yourself. So I'm Omkar Kher. I've been working at Rapid Circle for the last 7 years. Before joining Rapid Circle, I was running my own IoT startup, which was also built on Azure. This was back in 2011. We used to run most of these workloads on virtual machines, but now we have very fancy resources out there. And sometimes I feel visiting those ideas again would be a different story. Right now, I'm focusing on Azure at Rapid Circle for the last 4 years. I'm leading the Leap team at Innovation Lab, working alongside Shweta. And yeah, that brings me up. Shweta, you can take over.
Yeah, so my name is Shweta, and I've been working with Rapid Circle for 7.5 years, and been in the industry for almost a decade now. And as Omkar said, I've been working in the innovation lab team and working on these Leap suite of products for last 2.5 years almost. And yeah, working with Azure and excited for today's session.
Great. Okay. So with that, I think we'll quickly get introduced to this. We have mentioned this big word governance in our session. So let's establish some context here. The need for proper governance. Basically, we have been working with our customers to implement solutions on Azure and assist them in implementing solutions on Azure. So through consulting, through products, both. And through that, what we have seen is that resources always need to be vetted against various compliances based on the use case. So we have customers across in the energy sector, telecom sector, education sector, and there are various compliances that they inherit and they need to be applied. And they also need to be applied in context of business continuity. So there has to be a business continuity plan anytime you're planning something like this. There has to be a disaster recovery plan, especially focused on data. If there's data dependency on a particular process, you always want to ensure that there's a copy of the data stored elsewhere that can be used in case of an incident, in case of an unforeseen event. There's access control that comes under the radar as well, ensuring that proper access is given to only the people who need that access. And this also includes different categories of users, the business users, operations teams, administrators, the executive teams, so on. Network restrictions also play a role, and actually network restrictions sort of gets covered, but we always see a special mention for network restrictions when we talk about the cloud, because cloud by default is publicly accessible. And this becomes one of the most important topics to address when you are planning to move enterprise workloads onto the cloud, that you have proper network restrictions, you have a proper plan to set up a network that connects your on-premise services to the cloud. So these are just a few points. This is not an exhaustive list that comes into play the moment you're talking about governance. And governance plays a special role in cloud adoption then, because the moment we talk about cloud adoption, we start seeing these challenges. When we have these conversations, we have had numerous case studies internally where we have worked with customers moving their on-premise workloads onto the cloud. And the first hurdles that we see is the administrative team, is the operations team, security teams raising flags that they would always want to ensure proper controls. For example, for the administrative team themselves, they do want controls in their hand in case of an incident, in case of an event. They want to ensure that there's some sort of a break glass account or some sort of a master key that allows them to take charge of resources that a business would be using. Because again, there's this difference in mindset as well when you work with on-premise and the cloud. These are not hardware resources sitting inside your building. This is someone else's data center. So you want to ensure that you have these controls set up. If not, the administrative teams are certainly going to panic. Further, there are compliance requirements, as mentioned before. Depending on the use case, if it is a healthcare organization, it's going to inherit some HIPAA compliances if it's operating in the US, or if it's operating in the Europe, it's going to inherit some compliances if it's dealing with user data. If it's in an education space, even there's different set of compliances applicable over there. There's appropriate access that needs to be provided to business users. So that this process needs to be set up in such a way that if a business user is asking for a SQL database, that database, this proper access given to the business user and the minimal access. So the principle of minimal access needs to be followed there. And this is where the conversation, this becomes a huge part of the conversation as well, that before handing over any resource to the business users, the access needs to be trimmed down, for instance. Not everybody, if we speak in context of Azure, not everybody needs owner access. You want to have users who have just reader access, depending on the use case, of course, or just contributor access where they cannot control RBAC, so on. Further, there's also need for uniformity across the deployed resources. Now we are talking about operations teams or administrative teams. And if we look at an organization that is, say, 10,000 employees or more, the cloud setup starts looking chaotic very quickly if everyone's just going to the Azure portal and creating resources by their own way. You would have different kinds of naming conventions. You would have different kinds of configurations being applied. And uniformity becomes key because you have a large team. Even your operations team is going to be, say, 50 plus in size. And everybody needs to be aligned. Everybody needs to understand quickly. If they look at a resource, they need to establish context that, hey, this is a resource used by some of our data science teams. And this is a ML workspace. And these are the configuration that it's going to have. And if they see something odd over there, that flag immediately gets raised if there's uniformity ensured. So these exceptions are quickly standing out if there's uniformity. Further, the last but I believe the most important point is overcoming operational bottlenecks. And we emphasize on this point because with Leap DNA, we try to address more and more issues on the operational side. Because of the fact that operations happens after implementation, and that is an incremental cost if not done right, if the implementations are not done right, and if you're not enabling your operations teams, governance cannot be followed optimally. You will always have to ensure that the operations teams has the right tools in hand or right data in hand to understand what the state of the cloud resources looks like. So that's basically the challenges. What we have observed is some pragmatic approaches on our customer side. So when we started our customer interviews about 3 years ago, we started noticing that Azure administrators like to maintain PowerShell scripts, ARM templates designed to provision these resources. They apply the desired configurations on them.
So,
and there's nothing.
I have one question there.
Sure, go
on. This is, the governance perspective, right? How it is limited to the production or non-productions as well? Like, do you apply these to non-production infrastructure as well, or you're just limiting it to the production infrastructure?
Okay, so firstly, we do not influence the governance decisions. It depends on the customer how their governance decisions are going to look like. It can differ. We have seen customers who enforce these policies on their non-production resources as well. And we have seen customers where the non-production resources do not have this applied. So if you're looking for at a publicly traded company or something like that, usually the cases they will look at that. But if you're looking at, say, a university who is automating their cloud resources, these sort of compliances are a tad bit light. What we do as Leap DNA is enable the teams to apply their governance vision across their cloud landscape. So we don't influence that, and when we engage with them from a consulting side, we get that opportunity to do it. But as a product, we don't focus on those aspects. Our goal is to enable them to apply their vision. That's basically it.
Okay, so I mean, what is the trade-off? Like, what is, from your perspective, what is the trade-off for for the customers who don't apply this in their non-production? Like,
that's a very interesting question. So the trade-off is that you slow things down. Governance is usually seen as bureaucracy at times. So this tends to slow down your processes. But in some contexts, it is right to slow things down because you want to ensure that even if it is non-production, things have to be done right. And in that case, if you're able to justify, if as architects or as administration leads, you're able to justify the reason to apply these governance on non-production resources as well, then that completely makes sense. That's for your businesses to comply with.
Okay, Go ahead. Go ahead. Sorry.
So, yep, no problem. I actually feel free to interrupt in between. I think we can. There's value derived out of it. So what we saw with our customers is that administrative teams are having these PowerShell scripts, ARM templates that they use to provision the resources. And lately there's also Bicep, which actually brings a really nice structured way to execute it. If you want to have a blend of ARM templates and PowerShell scripts, you can do that very well. And there's nothing wrong with this approach. This approach works well. However, the administrators have to manually run these scripts or rely on, say, an automation account where they would trigger it against some sort of a ticketing system. So if there's a ticket raised, someone from the operations team goes ahead, runs this PowerShell script via automation account, via DevOps pipelines. This adds some manual effort, or this creates a sort of a glitch in this process. And this is where we started focusing. We saw opportunity to enhance the user experience across this space for administrators, for the business users themselves, and in turn for the operations teams as well. So administrators who would be creating these rules, governance rules, it could be IT enterprise architects who take these decisions and get all of these workflows, all of these scripts implemented. Whereas business users should have a better user experience in terms of how their ticket is getting processed, what sort of resources are being provisioned, how to access those resources, so on. And for operations teams to get an overview of what exactly is happening. Because if something goes wrong, business users are getting in touch with operations team to understand, hey, why did my SQL database not go live? And they are running against some deadline. Time is precious. If we start taking context of data science teams, this becomes more and more pressing. So with Leap DNA, we are basically focusing on a few features, and there's a trimmed down list of features that are presented over here that is relevant to the conversation. There's much more that we can discuss. But the first thing that we did is empowered the administrative teams to build the automation that provisions resources as desired. So let's say you want to have a service that deploys a Cosmos DB. What if the administrative teams want to ensure that the SKU for the Cosmos DB is supposed to be fixed, they're able to apply those rules to it, the naming conventions, the access controls that will be provided to the end users. They're able to do this on the platform using their own PowerShell scripts, using their own ARM templates. Whereas end users get to have these user-friendly forms where they can create the request, or even operations teams can use these forms to create a request against this automation. The goal is to reduce the need to build these forms. Custom solutions can always be built. Our goal over here is to package all of this and offer to our customers. There's also inbuilt APIs that get provided for third-party integrations. So you might have a ticketing system like Freshdesk that where your end users will create a ticket. Freshdesk can now integrate with Leap DNA and automatically trigger these workflows. We then generate the end-to-end usage reports for operations teams so that they get an idea of what sort of businesses are making requests, what sort of resources are being provisioned, what set of parameters are being injected into these requests. We also issue notifications for the progress made. These notifications are sent to the operations teams, to the business users, so that they know when the resources are provisioned. For example, again, coming back to Cosmos DB, a Cosmos DB may take 5 to 6 minutes to get provisioned. So the business user gets this notification once this resource is created, and they know exactly when to start consuming this resource. So that's basically the goal with Leap DNA. Again, there's a lot of features, but 1 hour is not going to be enough, and we'll focus more on the engineering aspect. So that brings us to how we have built it. So we have divided this flow into goals. So we'll go through 4 goals that we have narrowed down, and there's much more that we could talk about, Vivek. But for this session, considering the time, we'll be looking at 4 goals and then go through a demo of Leap DNA so that the audience can understand what is it exactly that we have built. So yeah, next slide. So the first goal that we are looking at is building the compute targets. So we are talking about provisioning resources. So we need some sort of a compute target where these resource provisioning logic is going to run, basically running the PowerShell scripts and ARM templates. So that was one of the first points in this goal. Second one was to evolve these compute targets gradually. What we have been ensuring is using principles of rapid delivery. so that our customers are able to experience our features pretty early on. You could even relate this with the lean principles, wherein we use a rapid feedback loop of delivering a feature to the customers, understanding how they use it, and then taking feedback from their usage and gradually optimizing it. And we wanted to do the same with the compute targets that we select to execute these PowerShell scripts and ARM templates too. And we also wanted to gradually improve the control on these targets because we'd like to explore some more territories. Tomorrow, we want to also execute bicep or some other infrastructure as code solutions. So we wanted that flexibility as well. So the way we pursued this is step one, we started looking at automation accounts. The reason for this was that our customers were already using automation accounts. This is a widely used practice. I don't think this is an exceptional observation that we have made. Automation accounts are widely used by administrative teams to run scripts across their Azure subscriptions or Azure tenants. So we started utilizing runbooks to execute these operations. But what we did here is the runbooks that administrators were using, we started splitting them into isolated runbooks so that these isolated runbooks could also be used and reused across workflows. So if there is a naming convention strategy that you're using, that single runbook can start being, you could start using it across provisioning of multiple resources. So applying some principles of reusability. But what we did observe in this approach is that the response time for automation account is a bit slow. Reason is you are not promised a vCore capacity, virtual core capacity when you go for an automation account. So in some exceptional cases, we used to observe that our runbooks are getting queued for even a span of 10 minutes before actually getting executed. And we are building a solution that is provisioning resources for business users, for time is sensitive. So we wanted to optimize this moving forward. We also noticed verbose logging was a challenge, and this is feedback from a developer's perspective over here. That if you wanted to run some diagnostic exercises against the automation account, if you enable verbose logging, the runbooks used to run a lot slower because of the internal operations. And runbooks are not designed for this kind of a use case. So we were retrofitting. So our expectations were being met in some ways. We also wanted network integrations done. We wanted to explore that, and that required hybrid runbook workers, which would require a virtual machine, which would add more costs. So these last 3 points, they motivated us to dig even further. Now, I've added a disclaimer over there. These observations are from 2019 to 2020. So if the Azure team has made any improvements over there, these observations might stay invalid today. So this is our mileage, your mileage may vary. Just adding a disclaimer there. Moving forward, maybe some of you might have guessed the evolution of the compute targets was functions. So we started considering functions around 2020, I think, or late 2020. Azure Functions went general availability with PowerShell. And that was like a moment of celebration for us because we could now rely on an infrastructure that is more in control for us. The speed of execution would be a lot better than automation account. We started relying on queue-triggered functions and bindings to get inputs and outputs for these PowerShell scripts that were running inside these functions. We started seeing opportunities. Sorry. We started seeing opportunities for network integrations by hosting the function within an app service plan or a premium plan. This made things a lot more acceptable for our customers as well, because we are talking about a high compliance environment. Network restrictions really made administrative teams happy. So we could run PowerShell and ARM templates out of the box. So this execution was sorted, and that's basically the state today. Excuse me. So yeah, that's basically functions. That's what we are doing today. What we are now exploring is this is something that's under investigation.
Just go back one slide. I have a question there.
Sure.
On functions basically. So you are using functions. So what was your request number of requests you expect on this? Is it minimal or it is high request you're going to get, and how are you managing that? I think it, because it is compliance, it is because it is governance which you're running, so it might not be like every time you are running governance test, right? So basically,
True.
you would just do a small, I mean, it would be a small request or interval. What is the interval of this request as well?
Yeah. So there's one point that I would like to establish over here, which maybe I should have established earlier. That number one, we leave DNA installations happen privately for customers. Again, compliance heavy environments. They do not rely on a SaaS solution. So it's a private installation. This gives us opportunity to fine tune the SKUs for the functions per customer, depending on the workload that we foresee. We have seen environments where the request workload can have a huge spike based on business requirements. So you could have provisioning requests of about 70 resources within a span of 3 hours. And the function is then busy provisioning all of these resources, running each step against each resource in parallel. And so that's basically what we have seen. And there's also environments where we work with universities where what we are foreseeing is depending on examination schedules and all, these workloads will vary. So it's actually difficult to comment on a specific pattern here that can vary, but we keep control of the SKU configuration. We can choose to decide that for a particular installation we can go with a consumption plan because, well, it's not going to be too busy and we're going to save up by using a consumption plan, let's say, or move to a premium plan wherever network integrations are required. So does that answer your question?
Yes, yes.
Yeah, I would like to add one more thing that you will see through the flow of this presentation as well. We have taken pragmatic approaches to ensure that our system, even if the load increases, doesn't go down. We carry out asynchronous execution, so that's coming up actually. So we ensure that that happens. Like even if the system is busy, the request will get queued and it will finally will get executed. So that's something that we've also implemented. So yeah, that would also
Yeah.
handle the peak load as well. Yeah. So should I go to the
Yep.
containers?
Let's go to containers. So this is something that we are investigating. Basically, Azure container instances seems like a very interesting offering because we start getting OS level control. So if you want to start executing workloads aligned with, say, even bash scripts or Azure CLI commands, that this sort of control would help us. That's what we are anticipating. Sorry, that's what we are anticipating. We also get the opportunity to pool instances. So we could have some instances parked already so that request execution becomes a lot faster. There are some cases where functions can face a cold start. And if we start seeing environments where you want to really be time sensitive, pooled instances, container instances can help us there. So that's something under exploration. So that's just a happy mention for container instances. So this leaves our first goal achieved. We are now able to have these various compute targets configured for us and start executing workloads there. The next part, the next goal, brings us to one more interesting story, which is building an API that can accept asynchronous requests. So we are talking about getting requests to provision our Azure resource based on how an administrator has configured it. But this request is, if you look at it from a HTTP call, this HTTP call is not going to tell you that, hey, your resource has succeeded. That's not going to work because the resource provisioning could even take 20 minutes. So this is basically a long running request. So we wanted to start accepting asynchronous requests while maintaining a highly available, highly reliable API endpoint for third parties, because we said took an example of Freshdesk integrating with LeapDNA. We don't want Freshdesk making an HTTP call and where we are taking 30 seconds to respond to their API call. If it's a third party service calling us, we want to make sure that they get some sort of a response quickly and then we take care of the rest. Then we also wanted to notify users or even services whether the request has failed or succeeded. So that's one goal that we wanted to achieve. So the way we pursued this is we start referring to the asynchronous request reply pattern, and Again, a happy mention for Azure Docs over here. There's elaborate documentation about in the well-architected framework. The asynchronous request reply pattern is well documented over there. The screenshot, the diagram you're seeing here is coming from there, wherein a third-party API in step one can make a call to a function or anyhow we have implemented that API, could be even an app service, which can enqueue a message. That message gets processed by another compute target, whatever we use there. And once the request is processed, we start updating the status internally. And there's a separate status API that is responsible to inform the client whether the request has succeeded or not. So the first API is going to give it some sort of a status endpoint or some sort of a ticket ID, which that service can use to continuously poll and check if that request has completed or failed. That's the pattern that we used. In the next slide, you will be able to see a sequence diagram that gives you a clear idea of how this works. And you can take, as developers can take a call of how the HTTP headers are populated over here, but this is the best approach to take, wherein you're responding with a 202 and informing the client that, hey, this is a status API endpoint. Further, the status API endpoint can give a redirect response whenever the request is satisfied so that the client can access the resource. So again, if you're really interested in going into the details of this pattern, Azure Docs, the link is mentioned below. Do take a look at that. So that's basically what the pattern that we referred to, and the way we have implemented it. Let's take an example of handling email notifications. This is what our design looks like, where a user comes to an enterprise application, could be a ticketing service, creates that request, that application sends us the request. We take it. We have used a service bus over here, and the reason for using a service bus is that we wanted to keep an option for various services to subscribe to the topics and get and react to the status updates. So there's a start topic which is used to pick up this message, execute this workload. Then there's a finish topic where once the workload is completed, that finished topic receives a message. So there's an email notification service that connects with Graph API and sends out an email to the end user saying that, hey, your resource has been provisioned, go ahead and access it. This approach also helps this to basically use the finished topic for various other services. We could even start exploring webhooks if you want to, using this sort of an approach. So that was basically our incentive for going with service bus. So yeah, I think those are two goals here. And for the next one, I'll hand over to Shweta. Maybe we can take a pause for questions. I saw some chat messages popping up. I see there's a question by Harsh. Would customers allow you to analyze their usage to evolve your product, as you said? Well, again, very good question. Now, because these are private installations for our customers, in some cases we do have access to our installations, and then we can observe how our services are reacting in production and take those logs, refer to those logs and optimize. And this works in our customers' interest that this data be provided to us so that we can optimize our operations. Of course, the privacy aspects come into play. So this access is trimmed down. We only have access to, say, our application logs. And Shweta has will be explaining some of these parts later. So we only look at application logs where user specific data is not exposed. We are not looking into some private data that is flowing through the system. We are only looking at application health, CPU usage, memory usage, the number of messages that are going through service bus, so on. So yeah, Shweta, you can take over.
Yeah, and adding on to that, the way we are presenting this at our customers is as a service. So it being a market service, it has a consulting arm as well. So we establish kind of a relationship with customers to get continuous feedback as well. So it's not always in the form of data that is being exported for per user, but trying to understand the pain points for administrators, and that's something that can come through the consultation that we do with them. Trying to understand problems in their usage of the product is something that we talk on regular basis and understand from them. So that's how we sort of analyze the usage as well, not only through logs. So yeah, that's also something that we can rely on. Okay, moving on to the next goal for us. It was important to orchestrate this execution request, right? So when we received execution request from our client, from any enterprise application or any third-party service, we need to ensure that all of that execution flow is orchestrated properly, so that we can, as Omkar said, we can report back the status. We can ensure that users are notified, and we can do different sort of things and manage this execution flow. So to manage this execution flow, we had few challenges, like we had long running tasks. So long running tasks, basically, because some Azure resources take like 45 minutes. For example, virtual network gateways take 45 minutes. And if you try to run that workload in Azure function, app service plan as well gives you 60 minutes. But then you have to ensure that that after that execution is done, there's some sort of reporting and there's some sort of feedback that comes to your central orchestrator, which will further then give response back to the client. So that was one of the challenge, managing event driven tasks like notifying users and when the status changes and so on. Then there was a need of parallel and sequential execution. So parallel execution, obviously, because we wanted multiple tasks to execute in parallel to achieve better performance, and sequential execution because there will be some dependent tasks. Something has to happen like pre-deployment, some scripts must run, some scripts must run post-deployment, like for example, putting RBAC rules over resources should run post-deployment. So certain things should happen sequentially. So all of these things led us to create some sort of an orchestration flow, and that's where we realized that we could use durable functions. So instead of trying to create this algorithm ourselves, Azure provides us this good way of orchestrating our workflows using durable functions. So Azure functions by default are stateless, right? So they don't they are for quick computations in cloud, where you want to get something quickly done and not worry about infra. But when you want to execute some sort of a stateful workflow, then that's where durable functions come in, and you can write orchestrator functions to orchestrate your workflows. So there were different patterns. There are different patterns, operational patterns, that application patterns that can use or can benefit from durable functions, like for example chaining of functions, like for a food delivery or order delivery system, you would want to rely on the state of the order and then execute a chain of functions like pick up, deliver, pick up, process, deliver, and so on. But for us, what was important was to be able to monitor the execution of these long running tasks. So what happens is when the request comes to our central system, the orchestrator, which is acting as sort of like a puppet master of our entire execution flow, the orchestrator sends the request to an agent, basically, which is the long running task, and which executes this probably an ARM template deployment or some PowerShell script that applies RBAC. And then it puts the result back into, or the status, continuously reports status to this storage resource, where it could be table storage, Cosmos DB, anything. And then orchestrator, after triggering this, keeps on monitoring this status through an endpoint, which is the status reporting function. So during this interval, it keeps on polling onto this status reporting function. And during the poll interval, the orchestrator sleeps off. So this is one of the great advantages of using durable functions, is that when the orchestrator is sleeping off during that polling interval, Azure is not going to charge you for that time. So after a few intervals, after a few seconds, orchestrator can go back and try and see whether that task is completed or not. And that's how this whole monitoring execution happens. And once the status is reported as succeeded or failed, the orchestrator can then move on to the next step. So what we are showing here is one step in this multi-step process, okay, which executes number of actions. So in similar fashion, so you can imagine the complexity of the entire orchestration when it's a workflow of multiple steps. So that was something that goal was solved by durable functions for us. Moving on, so now till now we have talked about how we have executed this, how actually the execution is happening, how's the compute happening. But the next goal and very important goal for our enterprise customers was to have monitoring in place. So they are trusting us with some of the most sensitive resources getting deployed on their Azure environment. So it was very important for them to be able to monitor what is happening through our product. So it was very important from the audit perspective. So audit, because they need to know who has requested for the resource, what exactly are the steps being taken. So all of these governance, so we promise that we will be ensuring all of these network restrictions and access restrictions are being applied. But how do they ensure that? They will ensure that through our audit logs. So there are audits happening throughout the operation that is happening. Then the most important thing for the business people, business users, is reporting. They need to understand how many resources are being requested, which department, for example, is asking for these resources, what kind of SKUs are they asking for. So Vivek, you asked about non-production production. So they have created these specific SKUs that they can use. So some of the customers ask us to enable only a few SKUs in non-production and few SKUs in production. So they need to understand whether this is happening, what kind of SKUs are people using, how is their cost spent based on. So their cost reports can then talk they can compare our reporting with their cost reporting and check whether this provisioning is matching. So all of that is important for our customers. And from so these are from this is from the point of view of our customers. For us, it is important, since we are delivering it as a market service, it is important for us to monitor the application performance. So we need to have logs that will indicate how many server requests are happening, how's our CPU performing, like how's our infra performing, basically, how what is kind of the usage pattern, and all of that. So for that, it is important for us to have logs that monitor the application performance, and end-to-end application operational monitoring. Like for example, having alerts to ensure that the status reports are going out and everything. So all of that was solved by one great solution from Azure, that is Azure Monitor. So all of these things are taken care by different offerings under Azure Monitor. So for application performance management and application monitoring, we are using application insights. So which is now moving on to log analytics workspace, I suppose. But right now, that's the state. We are using application insights. We are using log analytics workspace for putting all of our audit logs and report, so that log analytics workspace interfaces well with Power BI, and you can use KQL to query that data and so on. So that's where we are using log analytics. And so I'll just move on to the next slide to give you a better idea that our so function is basically our system, which is putting on all the application logs and application insights, and we are putting all audit and functional logs into log analytics workspace. So all of that reporting can be extracted out by our customers in choice of their reporting tool. Like for example, Power BI, they will create reports of server requests, reports of provisioning requests, which department is using it, and so on. All of that they can do in Power BI. All of these audit logs are also exposed through APIs. So these APIs can help customers build custom dashboards in their solution of choice. We also provide such dashboards on our portal. And we are using alerts for operational monitoring. Like for example, there are multiple jobs running in our system, and if a job gets stuck, for example, in production environment, for us, we have created alerts on Log Analytics Workspace to give us email notifications when a job is stuck for more than 24 hours, so that we can go and check whether there's something wrong in the system, if one of the parts is not working as expected. So for that, we are also using alerts quite extensively. So that that was the goal, that we get good monitoring strategy in place. So that was resolved by Azure Monitor's different offerings. Um, any questions till now, or can I move on to the next part? I think we have questions, or
Yeah, there's a question about
about
cold start.
orchestration. Yeah.
Yeah.
Yes. Yes, so sometimes the orchestrator has a cold start or even the function. So the functions that are acting as our execution agents, they experience cold starts. But how we have tried to overcome it is building a reliable queue. So even if there is a performance delay, so even if there is a cold start, the obviously function runtime also takes care of this, but our queues ensures that the message is not lost or the request is not lost. And so cold start is going to affect the performance no matter what. We try to ensure that functions are warmed up before the before we start actual live accepting live requests, but that's something that's not under our control most of the times. We are using Elastic Premium, where the scale controller for Azure Functions is also not under our control. So it when the function scales, if there is a high load of requests and the function scales, then there is going to be that instant starting delay in handling those requests as well. But yeah, that does come up. Secondly, just I wanted to add one more point on the previous orchestration bit, was handling failures. So for handling failures, like our agents sometimes experience restart or maybe unavailable due to some network issues. We have put in access restrictions at network level on our agents as well. So in that scenario, if the agent is too busy, our orchestrator tries to do a retry with certain delay interval, which is obviously returned by our agent. Also ensures that it returns proper response, like I'm too busy, 429 status code, and here is the retry interval after which you can try and reach me back. So that sort of implementation is also there for reliable execution and handling failures. And if there is a failure that is unexpected, then and there is like no response, no retry interval coming from the executing agent, then the orchestrator retries again, tries to communicate with the agent 3 or 4 times based on our configuration. And if still it doesn't get a response, then we report back a failure. Otherwise, probably in 1 or 2 tries, the network issue gets resolved and the request goes through. So that's how we have also tried to overcome the failures in the whole orchestration system.
So one of the questions I have is, what is the performance of having all of these things together, right? Say, for example, say 20 developers went out there and requested very different kinds of things, and developers or IT managers, whoever it is, and you'll have to go through all the compliance and check everything, and even before you get started with it, and then you know then there is a delay which gets kicked in because of the infrastructure which we need to create. um, how does that work in a real world scenario? I'm just curious from a performance perspective, like how does that work in a real world scenarios?
So do you want to take that, Omkar?
Yeah, I can take that. So, Vivek, there's two parts to this story. So, as I mentioned in the beginning, there's three types of users that we work with. One is the administrators who decide the compliances that need to be put in place. It's their responsibility. Their job is in the line if they don't take the right decisions. So they create these decisions and create the PowerShell scripts, ARM templates that need to be used to provision resources. This happens first. So this is part of the process. So if an IT admin team is going to say that, hey, as business user, you're able to provision a ML workspace. So if you're provisioning an ML workspace, the first thing that's going to happen behind the scenes is the administration team is going to decide the process of how the ML workspace is going to be handed over to the business users. All of those decisions are going to take place a lot before even the idea of making such a request occurs to the business users. Once this is in place, this is where Leap DNA helps to host these workflows, orchestrate these workflows. Some of these finer details are interesting, but due to time constraints, we won't be able to. Maybe during the demo, some of those could be clarified, how the user experience looks like while doing this. Then comes the part where business users can use a form or a ticketing system to request for this particular ML workspace. So the rules and the scripts and everything is in place. And let's say day one itself, 20 engineers go ahead and start making a request that, hey, I want an ML workspace. That's where the real value of Leap DNA starts showing up, because we start using the design that we have implemented to provision these resources in parallel wherever possible. There are some exceptional cases where we do sequencing as well. So the requests are always sequenced one after the other. But those are exceptional cases where we don't want race arounds if there's dependencies and so on. That's basically our value proposition, that if there is a high workload of requests coming your way, then our solution should be able to cater to it. And we are evolving. We are trying to optimize our solution to cater to more and more requests. And that's the reason why we are continuously investigating the compute target space. To understand that we get finer control, we reduce these breaks in between. Of course, you're looking at the design in bits and pieces. At this stage, we have all of this designed in a very tightly coupled way, wherein the communication is optimized to a great degree. Again, using the MVP philosophy in the beginning, things were not as optimized as you would see today. There used to be delays, or even with runbooks, or even with functions, the way things were wired up, there used to be delays. But gradually, we were able to understand these aspects and then fine tune them. And our recommendation to architects is that you have to get this in shape, see your system perform, and there are some bottlenecks that are always going to be obvious once your system starts working. We have always, in many a times, our customers have surprised us with certain use cases. And then we are able to highlight some of these bottlenecks on priority. Then that's where the product owners come into play to, highlight that these are the bottlenecks that we address first, and there's some things that as engineers are obsessed about, we can handle them at our own pace.
Yeah. Yeah, and also about the request load, as if 20 requests are coming in at a time, anyways, the solution is a step up to the kind of delivery they were earlier getting. Like with these sort of processes, if automation is in place, first step is getting the automation in place, trying to remove the manual intervention. So there's going to be approval flow, obviously, but somebody trying to trigger a wrong run book is also going to affect the entire process, or somebody forgetting to add a contributor role is also going to affect this process and the performance in general for these people who are requesting for it. So once you have the workflow in place and automation in place, that's going to immediately give that relief to the user base, that okay, initially it was taking 12 weeks to get my ML workspace. Now I can get it in, like, considering all the compliances, I can get it in a day maybe. So that is a huge step up when this type of workflow is already defined. So yeah, also.
I mean, there are a couple of questions. Do you want to take it now or probably at the end?
I think let's take them at the end, because there's a demo that we can go through and we can address them.
So quickly moving on to our CI/CD strategy. So for our customers, as Omkar said, we are deploying it as a market service. So we are so obviously the source code is owned by us, and we are exporting these binaries into the customers environment, Azure environment. So we are deploying it in customers Azure environment. So we have to have a solid strategy so that there is minimum delay and as less downtime as possible. So first of all, we are provisioning our infrastructure through pipelines, DevOps pipelines. We are using PowerShell scripts and ARM templates to do that. So we practice what we preach. We don't go to the portal, or we don't do right-click publish. We ensure that everything is provisioned through DevOps pipelines, and strictly following the guidelines that we propose should be, uh, should be used by our customers as well. So for example, the storage account will always be HTTPS enabled, whether it's being used by us or being provisioned by us. So that's one. Then we use DevOps tagging. So these are a few features of DevOps that we have really found useful. That's why some mentions over here. So DevOps tagging is something that we have started recently using because some of the customers have strict deadlines based on when we can release onto their production environments. So we cannot maintain different branches of our production environment. Instead, we have used DevOps tagging on our builds so that a certain customer gets the particular feature tagged build, and other customer doesn't have to wait for the new build to be received, but the source code on our master branch stays the same. Then we have used application configuration. For that, we have extensively used the variable libraries in DevOps, wherein we have managed a different library for different customers and different environments. So we don't get lost in that app settings files hell. So we have the great UI from DevOps, wherein we manage all of our variables, configuration variables. And we have also started implementing blue-green deployment. That is where we are using deployment slots. So this is the new term that is being used to avoid to avoid any downtime. So for that, we have used deployment slots. So we ensure that all of our releases are done onto the secondary slots first, and we ensure that everything is working fine as expected, and then we release our build to the production slot. How do we ensure that everything is working as expected is something we have created health API endpoints which talk to all of our dependent resources or dependent services like storage account, and all of these SDKs also provide these health APIs. Which we've used to ensure that storage account is connected, network configurations are in place, and everything is accessible basically. So if storage account connection string is missing from our configuration, then it is very obvious when we try and reach it through our health API, and it says that unhealthy. So all of those health checks happen on the secondary slot, and then we move on to the primary slot for actual going live. So that is sort of the strategy we have been following on the market service. And so that's it about the CI/CD. Moving on to actually as a retrospect, what we have observed is we have with the kind of serverless offerings that Azure has provided. Omkar also mentioned it. It was very easy for us to build a minimum viable product for our customer, validate our plans, or validate our imagination, like how the system would work through quickly building endpoints through Azure functions, quickly putting up APIs against or KQL against log analytics workspace. All of these offerings have helped us to rapidly create prototypes and get them validated from our customer, and establish that continuous feedback loop. So that is great offerings from Azure. And then now we conclude on sort of the engineering aspects, and we can go on to the demo of our product. And then we can go on to the questions, right? Okay, let's Vivek.
Yep. That looks good. What I've done is I've answered some questions in the chat, and post demo I can elaborate more on the answers.
Okay, so this is the dashboard of our product. It's called Leap DNA. So this is a quick overview of the requests that have been, queued recently by. So you can see you can see the name deployment plan over here. So deployment plans is nothing but what we are calling our workflows. Basically, deployment plan is the entire workflow, which is divided into multiple steps. So I'll quickly show you a deployment plan, how it looks like. I don't think I have it opened. Okay. So this is a deployment plan that provisions SQL database along with its along with the SQL server on customers Azure environment. And as you can see, there are multiple actions over here. These pieces are again created considering reusability. So we can use the generate resource name action. You can see that it has been called 3 times, or it has been added 3 times for different sorts of inputs. So generating resource name. So the code basically behind this is the same. The script is the same artifact script is being used, but with different inputs for generating the name of the SQL database for server and resource group. As you can see over here, they are being we are defining the language we have used over here as PowerShell. So we have written all of these scripts in PowerShell, but this over here is an ARM template which actually deploys the Azure SQL database. So these are the steps or actions, we call them, within the deployment plan, and they are sort of chained together to be executed one after the other in once the plan is triggered. This entire flow has a set of inputs that are to be provided so that the system knows what needs to be provisioned based on what parameters. So the variable things like location might change, or who's going to be the server AD admin, which subscription do we want to deploy it on, and so on. So quick, we
So
have
these
given a
deployment plans
yeah.
are being designed by the admins, right? So
Yeah.
they sit here
So
there and they
Yeah.
plan this out and they say, okay, this
yes,
is the SQL server and these are the things need to be there in the SQL server. If somebody is provisioning an SQL server in productions, these are the things which needs to be there
yeah,
from a compliance perspective, and they have already designed it and that has been saved. And whenever somebody is provisioning it, it's provisioned the way the admins have designed it.
correct, correct.
Is my understanding correct?
Correct, exactly.
Perfect.
This is what is
Perfect.
happening over here. And this view is basically for administrators to understand what they have created, and even they can go and edit this. So this is basically nothing but a JSON format of it. This is a feature that is under construction, so I was not going into the details, but this is what probably a admin would go and try and change things over here. And the end users will not see this view who are trying to request for these resources. They will see this create request sort of a button wherein they get this form, or sort of a wizard experience wherein they can put the details and just copying the subscription ID. And you can add some sort of an email notification for the end user who are the stakeholders. You can even add as a comma separated list. Review your request and submit it. So this is the quick view that end user will get, and it'll know that your request has been queued, and you don't have to wait around to get the response. You can go and track this request on our track status page, wherein all of these actions are being displayed one after the other. As they execute, the status will change. You saw the notification email part where I'd added my email address. So sorry, trying to drag the window over here, and
So
I've tried the
question
wrong.
there.
Yeah.
So if I'm creating a SQL database or anything else as well, I need to have connection strings or probably I need to get those information.
Yeah.
Um, will that be shared in
Yeah.
this
So this is
or in the email?
yes. So not in the
How
email. I mean, yes, in the email as well. Once the output is successfully provisioned, but that will again depend whether this information needs to be in an email or not. So connection string is a sensitive thing, right? So what we do instead, or what we've seen and admins do instead is so this is a sort of a trimmed down provisioning flow. But what happens usually after provisioning is RBAC. So the concerned people, like the requester, will get contributor access on the resource, and they can go to the resource, and on the portal they will get all the information that they are supposed to get. So again, that administrators can decide what level of information. So let's say they are providing they need blob storage, right? And they need access on the storage account blobs and not actually on the resource. Then they can provide particular role like blob contributor or blob reader, so that the user who gets the notification, okay, your blob is ready, blob store is ready, you can go and on the portal and only see those blobs or contribute to those blobs and not have any access over the storage account resource as such as in handling the network restrictions or RBAC on that or anything like that. So that is usually achieved through the RBAC. So Azure has all of these features. We are just enabling those scripts being orchestrated through this workflow. So all of these details sort of come in the output. So if in actual environment, so this is the prototype, as I said, in actual environment, we create these security groups to be and add the requesters on those security groups, and information of those security groups come in the email as part of the output as well. So I'll show you that output email as well. Where did my email window go? Yeah. So this sort of a email comes to the requester or the notification email, where the track status link is given, what are the inputs, and your request is being queued, and we will get back to you, sort of a thing. And once the plan is succeeded, like for example, this is a successful plan, these inputs are displayed, and the outputs are also displayed. So this is the information that is required by the end user, like what was the resource group that was created for this, or where was it deployed, what is the name of the resource, and the server name. So with this, now the user also will get some RBAC access on the resource, and then user can go onto the portal and explore that further. And if there is some security group being created, we also add the security group details, the member details, what sort of like reader security group, who are the reader members, if there's a contrib, then who's the contributor, and so on. All of those details also come up over here, and all of that is displayed also in the success notification that the user receives for SQL database name and everything. So it'll also have that, some errors and warnings if there is a failure, that also comes up over here. And in case of a failure also, so that happens, right? I mean, even for Azure, there are sometimes there are failures in ARM template deployment, or sometimes there could be a failure on our system. There could be some failure in the way this is organized. We rely on some persistent storage for getting some user information that could be misconfigured. In that scenario, there's going to be some failure. Yeah. So in case of a failed plan, we also show some sort of a log why it failed, and other debug logs also. You can go into the details of this, see even debug logs or other logs that the action script writer, the PowerShell script who has written this, can add informative or debug logs for identifying the issues. And we give the option of retry and resubmit. So retry is basically you can try to execute this from provide some reason why are you retrying, and confirm that, and then try and execute this again. If there was some misconfiguration, you can correct it and retry this. Retry is basically allow you to start from this. So now this workflow has only one step, but it usually starts from the step that the workflow has failed on, the deployment plan has failed on, and resubmit basically just starts from the beginning. So there's going to be different use cases when you want to start from the beginning, but you have to be very vigilant. The admins have to be very vigilant when they are doing this operation, because considering the way they have orchestrated or they have written this deployment plan, they have to ensure that nothing is happening twice. Obviously, with ARM or provisioning, they are idempotent operations. So if template gets executed again, there's probably not going to be an issue. But if there's some script that is you've written and you've not ensured that if it's not re-entrant, there could be some error. So these features have to be used very carefully. So we give access to do this to only high privileged administrators who can retry, make that decision and do a retry or resubmit. the request. So that's another feature. Apart from that, we have a lot of administrative features on this, managing users, handling access control, and all of that. That'll take a lot of time probably. So we'll not go into those details, but that's more around our product and how actual the deployment plan execution happens.
So net, the whole of this product is working with Azure Functions
Yeah.
and some service bus and other things with that and storage. That's it.
Yeah. And
Or
Yeah,
is
I
there
think
applications
there's
for,
there's a there's
Amit?
much more resources in
yeah,
there.
Okay.
there's
There's a API services as well that
API
play a role.
services
There's SQL databases as well. But we
for
have tried
access
to give
control.
you a quick view of some part of the architecture
But the ones that you've mentioned
because
actually are the heroes who
Hero.
perform the execution.
yeah.
All of other parts are basically the supporting characters who are, for access control and all of that, user management. Obviously, there is an app service at the front handling APIs. So, yeah, that's
Yeah, I think I think Rashmita has opened the mic. So if you have any questions, you can unmute and ask questions to Omkar and Shweta directly. Anyone has any questions?
Hi Omkar. Hi Omkar, Harsh here. Um, so I had a doubt. I don't know if
Yes.
it's if I misheard you in the beginning, but when you're talking about governance, yes, you talked about giving the administrators control and all that stuff, but you also talked about, I think, following certain practices that are laid down, like certain like for example maybe GDPR or some other document that is laid down. So where is that being taken into consideration here, or did I mishear you
So
saying?
no, you heard it right. But our goal is basically to enable administrators follow the compliances. As a product, we don't influence any of the compliances because that compliance landscape
Ah,
is varies a lot across customers. What we are trying to do is provide a generic solution that can address. If you have clarity on your compliance requirements, we'll enable you to pursue that. So if you have GDPR compliances applied to your resources or HIPAA compliances or anything as such, if you have guidelines, if you have the roadmap in mind, and you need a tool to implement that, Leap DNA becomes that for you. So I hope that
got
clarifies
you.
things.
So Harsh, just to add, uh, cloud providers, specifically, they provide on the flies couple of policies which you can apply.
yep.
So as an administrator, what I would do is I would go and apply these policies, whichever needs to be applied. Like for example, when you talked about the HIPAA compliance or the GDPR compliance, there are a couple of things which you can enable through a policy perspective. And what the product is doing is on top of that, there is a specific compliance which they need to apply from a management perspective. For example, which they talked about, like one of the example which I just shared, you have a SQL database, and when you're deploying an SQL database, I need to deploy it in a such a way that I need to maintain a couple of, already enabled things on that, right? There is so many configurations which you need to do. As an administrator, every time somebody requests something, if I keep doing those configurations, a lot of checklist, and it's very difficult to do that. And one of the ways
Yeah, got
which they will be helping you is they would give you a template, and I would use the template and set it up for anyone to go back and submit it, and then use that specific thing. So in a way, it complements with the already existing policies which is out there. This provides on top of this, it provides a different kind of usability and use case for different use cases. It provides way for administrators and developers to use this one. Uh, since it is HIPAA compliant and other things which you're talking about, it's something, a lot of understanding needs to be done from the policy perspective. So you need to go through
Right.
each and everything and enable those policies. And that's something which you can do. So if you need more information, you can check the Azure policies, which is
Yeah.
there. You can apply it on different resources. Interesting, to go through it. It's something which most of developers we don't, go and see
Yeah.
all of these things, but it's an interesting topic. Just take your time out and see how it all fits in.
Yeah, so I just want to add one thing over here that Azure policies is something that is going to ensure that if there is non-compliant resource on your environment, which is defined by your organization, and it's non-compliant, then it's going to flag it, and then it's going to be a reactive action. What our solution does is enables you to deploy it in a way that it will not be non-compliant. So it's a sort of
But
enables you to ensure that in the first place you are deploying compliant solution or compliant resources so that it doesn't get flagged onto your security admins policy dashboard that okay, this resource is non-compliant from this department, so that these departments then can ensure that everything is as per the policies. So policy is sort of a fallback.
got you. Thank you, all three of you.
While we are waiting for some of the questions to come in, there is a survey link and there is an event ID. Just go to that link and just key in that event ID and let us know how this event was, and share your feedback so that we can improve this whole process for you. Yeah, I mean, we still have, I know we are over time, but we can still, do 2 minutes. I know it's Friday evening, it's 8 o'clock, it's bad time. But yeah, we can do 2 more minutes, and if you have any questions, we can definitely go for it. So there is a question from Aditya asking about, apart from the resource provisioning, how things integrate accessing user data, maintaining data governance using services like Azure Purview. Sorry.
Yeah.
I'm not aware of Azure Purview. I need
So
to.
I think it is for data resources. So coincidentally, so again, so they all of these policies and Azure Purview is also something that's going to ensure that your data is following the compliances and user data is managed and everything. But so all of this is decided by the subject matter experts. We are sort of enabling these SMEs to put their compliances, ensure that they are being followed in the most easiest way possible, and also allow them to quickly change it or evolve it. So, for example, Azure Purview has recently come in, or there are different policies that Azure keeps coming in with their security benchmarks and with their security baseline and everything. And governance governance model that they have. So these changes can also be quickly done when these workflows are maintained in proper managed way. So they can go to the portal, add a few lines of script and ensure that this setting is enabled. Like for example, say SQL database has transparent data encryption enabled or not. All of that they can quickly go and change onto the portal, on our portal, or even in the scripts maybe, and ensure that everybody throughout the organization is now using this particular plan to deploy. So that's how we are enabling these services to be used. So we actually don't have expert opinions on how data governance should be done, or
Right.
we just take inputs and try and build workflows that will help these SMEs.
I think I'll add one quick example over here. Maybe that gives a clear picture. Let's imagine there's a publicly traded company and there's a database that's being used by either their data science teams to analyze their internal financial information. If it's a publicly traded company, there's some things known as under compliances known as a no traders list. So if you have access to certain financial data, you cannot trade on the public list. The way this works is now Azure provides some very sophisticated tools like PIM, Privileged Identity Management, which will provide you time-bound access to this database. These tools are there, but to orchestrate these tools, LeapDNA helps you. So you can create a database and you can ensure that there's a PIM configuration associated with that database when the database is provisioned for the end user. And when they want access, they go through the PIM process before they can access it. And the PIM process then can be linked to a no traders list where you can say that, okay, this user accessed this database. There was a PIM access request. So the user automatically is sitting inside some sort of a no traders list. That's how LeapDNA plays a role. So the decision always remains with the customer. We help orchestrate all of this and help with the end-to-end user experience.
I think there's one more question about any plans to support providers other than Azure.
So Vivek has took the decision for us. Well, as a business, we don't say no, but it's important to understand that we are built Azure first. Yeah, so it's technically possible. If there are use cases that come around the radar, we'll do that. But we work around the Microsoft ecosystem. So we are, and our consulting expertise comes over there. So that's where we are aligned. But again, we as a business, we don't say no to opportunities.
Yeah, we are able, but we are just not doing it right now.
Cool. I think we're just done with it. Thank you, Omkar and Shweta. This was a very informative session and a lot of learning. And thanks everyone for joining in. It's a Friday, it's a Friday evening and we are just overtime, but thanks everyone for being here and asking so many questions to Omkar and Shweta. Thank you very much. Rashmita, you have
Thanks.
anything? Yeah.
Yes. Thank you, Shweta, Omkar, and Vivek for so much for doing this amazing session for us. And thank you all for joining us today. Please feel free to share your feedback about today's session. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and happy weekend.
Great. Thanks, everyone. Thanks for the
Nice weekend.
Thank you,
opportunity.
everyone.
Thank you. Bye-bye.
Thanks, Vivek.